Hello everyone. Think about this problem this way. Imagine you're a parent and you have a son or daughter or a close relative and they take a counterfeited drug and they die the next day. 1 million people die every year due to counterfeited drugs. 60 to 70% of all the drugs in the developing world are counterfeited. And the developed market is also entering our market between 1 and 10%. This is a really big problem. Estimates now, with the inclusion of India and China, show that the market is going from 300 billion to 400 billion in just 3 years. Of the 300 billion, 70 billion is accounted for counterfeited drugs. Now this is a really big problem. Pfizer alone last year lost 7% of their $1.4 billion market on Viagra alone. Now, what are people doing with this? There's not a simple solution, but we here at Holograms International, we're proposing a technology that is proven to be directly printed on packages, not the packages, not on the boxes, but on the blister packs themselves, and eventually on drugs.
I would like to begin by drawing your attention to a simple t-shirt. I'd like you to think how many t-shirts do you have at home? How often do you buy t-shirts? How often do you wear them? How do you treat them? Do you wash them? Do you iron them? And also, how do you choose them? Do you choose them based on a high quality or the lower price or the way they look? Well, I'm assuming that all of you know that t-shirts are made of cotton. And also that cotton is one of the most unsustainable crops for fashion and clothing production. It requires 2,700 liters of water just to produce the cotton that's necessary for one t-shirt. And that doesn't include the water that's required for post-care. That doesn't, the environmental impact of the t-shirt doesn't include the waste, the land that's depleted for the production of the cotton for that one single t-shirt. The environmental impact of a t-shirt doesn't include the CO2 and energy that's required to transport the cotton from the production place location to the mills and then to the end point when the t-shirt is manufactured and then sold. I'd like to present to you Couture. Couture is a new material. It's made. It's not made from cellulose and it's not made from protein. It's made from chitin and it comes from mushroom mycelium. What's unique about this material is first of all the way it's produced. So it shortens the period of production. It's manufactured in the factory of the future.
Good afternoon, everyone. I would just like to ask everyone a question. Do you know someone who has cancer or who has lost someone close to you with cancer?
Yes.
I mean, personally, I have a classmate in college who contracted brain cancer, and I lost him within a year. So, I mean, the whole point about cancer research is that they're using the average behavior of groups of cells. They're trying to find out what happens to groups of cells, and trying to solve the problems from trying to research about the group of cells. But should we be taking the average behavior? Take a look around you, to your left and to your right. Everyone has different hair color, everyone talks different languages, everyone's in different research, things like that. Can I just say that since there are like 2 billion Chinese people around, should I say that you, as an average, you are a Chinese person, or you are a 28-year-old? So what we want to get rid of is this kind of average behavior kind of research. We want to be able to focus down on the thing that matters, the single cell. On the cellular level, that's what we want to achieve. We want to be able to differentiate each individual cells from each other. And if there's no such thing as an average person, there should not be such thing as an average cell.
How many of your people are taking pills? And how many times do you forget it? And daily, thousands and thousands of different people are taking from high school are taking blood pressure, a lot of medicine.
So the idea is that we develop a nanochip that you can implant under someone's skin, maybe similar to the types of contraceptive implants that people are using nowadays. But the main advantage is that we'd be able to administer a cocktail of different drugs. And
So, John Wayne, Bob Marley, Ingrid Bergman, and last but not least, since I'm Italian, Luciano Pavarotti, Big Luciano. What they have in common? They died from cancer. So I don't want to give you a medical definition of cancer, but because everyone has got a personal story about the cancer, related to friends, family, colleague. But it's clear that cancer is not only a very big health problem, but also an economic problem and a social problem. And half of the people with a diagnosis of cancer are taking wrong medicine. What does it mean, wrong medicine? Useless poison, waste of time, and a huge waste of money for the health system. So, we are developing a cost-effective, quick and easy-to-use diagnostic system to detect a new class of cancer biomarker in order to optimize the treatment.
One of the most important problems in our sector is the pollution. In Europe, it has been estimated that 3.5 million sites are contaminated. And the cost of contamination is about 17 billion of euros. So one of the most methods used for the cleanup of soil consists in the physical-chemical method. Usually this kind of method are really expensive because can be applied for the remediation of large areas. So on the other hand, phytoremediation is a cost-effective method because once the cleanup soil is completed, we can use plants for the production of biomass and convert the biomass in bioenergy. So we have, at the end of the process, an economical return. Our company are developing different plants that grow in association with engineered microorganisms that are able to degrade a wide range of pollutants.
First of all, let's face the problem. How many people are there around the world at the moment? Who does know that? 7 billion, you're right. Do you know how many people there will be by 2050s? Actually 9. So by 2050s we'll have 9 billion of people in the world, and we'll have to feed every one of them. At the moment, the grain resources are running down, running low. So we actually have to provide another innovative solution. How do we provide with food the population? So what did we come up with is 3D printing. So
not only is 3D it will produce food to fill our stomach, but it will also fill our creativity.
A number of years ago, we lived in Nairobi, Kenya, and we came together writing a book called African Coasts and Oceans. In fact, we just edited the book. In fact, we actually met in a bar and decided that we would do.
Right, we did do the book.
But we did finish the book. Both of us found that we're both passionate environmentalists, passionate about natural resource management, and we're passionate about climate change. After our Kenya time, Stefano decided to come to the University of Cambridge, and I decided to go to Asia and work on other climate change issues. I've been working a lot on climate change adaptation, and climate change finance. It's a big problem, as you already know. It looks like we've done 100 years of damage already to our poor little planet. It makes us all slightly worried. But one of the things that we need to do is find better ways to do natural resource management. Traditionally, we've done projects and carried out ways to carry out different types of environmental projects, but there's been very little scale in this work. You do a project, that's the end of the project, it fails. We're looking to propose different ways. Some of the things that we've learned have come from Kenya. Perhaps Stephanie, you can explain some of the things that we've learned from the coast in Kenya.
Yes, so I'd like to take you now to the Kenyan coast, which as a development agency yourself, working on the Kenyan coast, you're quite familiar. Some of the issues that are faced by the populations there are malnutrition, an enlarged social disenfranchised population because there are much less resources available that are used for subsistence use of the reef. And that's actually what we'd like to talk about. So, as you know, there's been a standard quo, a way of doing development and environmental protection and rehabilitation in these areas. And what I'd like to talk about is we've been applying something in the agricultural area of Kenya already. And we're looking now to see if we can go from what is the status quo, from a donation of goods and services to a coastal population, which has typically been in terms of equipment or education for a change in livelihoods, to instead have one, as we've done in the Kenyan agricultural system trials, where it's a smaller amount of money and it's a continual supply of change. And that change is in the form of payment for ecosystem services attached to micro or loans that are actually taken up every year by these fishermen because they need this money to do their work.